This is number 2 in our series of basic machining operations on the mini lathe. This one will be about drilling. Well, I thought it would be interesting to start out with an actual demonstration of drilling on the lathe. And I think the thing that's interesting about it, particularly if you haven't seen it before, is that unlike most other drilling operations, in a lathe the work turns and the drill bit remains stationary. In just about any other type of drilling situation, the work remains stationary and the drill bit turns. A significant advantage of drilling on the lathe is it tends to make the drill bit self-centering. So you're more likely to get a hole that runs right down the midline of the work. Anytime you're going to drill into the end of a workpiece, it's good practice to always face the workpiece. That'll give you a smooth surface that's even and square to the work, whereas a rough surface might snag the tip of the drill bit, and the drill bit, being a little bit limber, could be pushed off to one side. After facing the workpiece, the next step is to drill a short starter hole with a so-called center drill or center drill and countersink. And these typically are double-ended drills that are short and stiff, and they are used to start the hole so that it's exactly where you want it. If you start the hole with a twist drill, there's a possibility that the drill will flex a little bit and not be exactly on center. This is a typical set of 5 center drills, and I've included a penny here for scale. And for those of you who may be interested in such things, this is a so-called lead penny made in 1943 when copper was a very valuable resource for World War II. They made a lot of pennies that had little or no copper in them, and this happens to be one. So just thought I'd throw that in for entertainment value because I found it in the drawer over here. But these, this is a number 5, a number 4, a number 3, a number 2, and this one happens to have a broken end on one end, and then a number 1. Now these are typically sold in sets like this, but you can buy them individually in packs of 5 or 10 or whatever, or 1. And you can also get bigger ones if you have a big lathe, and you can also get smaller ones for specialty work. And they look similar to the number 1, but it has a very fine point on it, as you can hopefully see. And this is an import one that has an unusually long tip on it. And the only problem with that is if your drill chuck is a little bit off center, and as a result the tip will break off, like has happened on this one. So if you have a choice, try to get one that don't have these real long tips on them to avoid that problem. Now, as far as which size drill to use for a particular job, you want to choose one where the diameter is just a little bit larger, or about equal to the diameter of the hole that you're going to be drilling. But if it's smaller, it won't matter too much as long as it's not real small. But you want it to make a big enough hole to give your drill bit a good start, is the whole idea. Now, let's say I want to drill a 1/4-inch diameter hole in this piece of steel stock I have in the chuck here. So I'm going to select this number 3 center drill, and we'll drill our starter hole with that. When you put your center drill in the chuck, as you're tightening it down, before you tighten it real tight, give it a twist like this. Then if there's any grit or chips or anything, either on the jaws of the chuck or on the drill bit, they will tend to get wiped off and end up in the spaces between the jaws rather than underneath the jaws. So that will not only give you a tighter hold on the center drill, but it will also avoid the possibility of having a chip under there that might cause it to, be skewed to one side or the other. And once it's in place, you can tighten it down with your chuck key. And a lot of times I like to use 2 holes. And for that reason, I try to keep 2 holes accessible, but in this case I have the chuck twisted a little bit more towards the bottom than I would like. Usually there's enough room that you can have the carriage out here somewhere, but you want to keep it well away from the chuck and the rotating work if you can do that. Drilling operations are one place that cutting fluid is particularly important. So I'd like to put a few drops of cutting fluid on the tip of the drill bit and maybe on the surface of the work as well. and that will help the chips to flow smoothly away from the cut. But especially with aluminum, the chips have a tendency to weld themselves to the tip of the drill bit, and cutting fluid will help quite a lot. Now I use typically a brand called Tap Magic or Tap Magic Aluminum if I'm working with aluminum, but there are other good brands as well, and some people use WD-40 with aluminum and seem to get good results with that. Now I got this Tap Magic in quart bottles quite a few years ago. A quart is quite a lot of this stuff. You only use a few drops at a time, and this is probably at least a 10 or 15 year supply, even for me, I guess. But for the average home shop, just a 4-ounce can is all you really need, and that'll probably last you a year or two at least. So, but in any case, this is the Tap Magic Aluminum, and I use that only for aluminum. And then this other variety here is just called Tap Magic Cutting Fluid. I use this plain Tap Magic for just about any material, and in fact they list on here a whole slew of materials that it's recommended for, and I think even aluminum may appear on, yeah, even aluminum appears on here, so you can use this with aluminum as well, but I've always had good luck with the aluminum specific stuff, so I stick with that. I've got my tailstock locked down, I've got my drill bit up close here. We'll start up the lathe and start drilling our hole. Okay, now that we're done with the center drill, we'll remove that from the chuck, and now we'll get I'm going to use a 1/4-inch diameter drill bit to drill our hole. This is our 1/4-inch drill bit, and it's about mid-size in terms of length and diameter in the sets, but you probably all have seen the common sets of 29 drill bits that range from a 1/16 of an inch up to a 1/2 inch in increments of a 64th, and I use those so frequently I have several sets of that type. But these are what we call jobber length drills, and they're the most common ones that you'd find, you know, at Home Depot or Lowe's or any place other than a specialty machinist supplier. But in the world of machinists, there are other drill bit choices, and you can buy sets like these that are called screw machine drills, and it's the same typical set of 29 sizes, but the difference is they're very short and stubby. And these can be a great thing to have, particularly if you have one of the shorter lathes. If you don't need to drill a real deep hole, you have these short stubby drills that tend to not flex as much, but they also don't take up as much of the space between the tailstock and the headstock, so they may enable you to get a job done where your ordinary jobber drill would be too long to fit on your lathe. The only thing about the short screw machine drills is they're typically going to be more expensive. You're not going to find the cheap sets like you'd get at Harbor Freight, but you'd probably pay, you know, $60 to $80 for a set of 29 of the screw machine drills. But I just looked them up on Amazon, and you can find some good sets on there. And typical suppliers like Schar's or MSC would have them as well. Well, let's suppose that our project plan calls for drilling this 1/4-inch diameter hole 3/4 of an inch deep. So first I want to make sure that my scale on the tailstock ram is set to the 0 position. So I'll just withdraw that until it's reading 0. And then we want to bring the tip of the drill bit right up until it starts to touch the work. Now, there's a little bit of an ambiguity, you know, where does the drill tip end, or where do you measure the depth to? The point or the place at which it starts to be full diameter. And I don't know the answer to that. It really depends on the specs of the project you're working on. So I typically bring it up so that it's the cone of the drill bit tip is just started down into the hole left by the center drill. Then I'll lock my tailstock in place. I want to put some cutting fluid here on the drill bit itself, and far enough up so that it's lubricated up to the length that I'm going to drill the hole, which in this case will be 3/4 of an inch. Now, as far as the rotational speed to use, That's something you'll have to judge by experience, but the general rule is smaller diameter drill bits, you want to use a faster speed. Larger diameter drill bits, you want to use a slower speed. And harder materials, you want to use a slower speed. So within those parameters, you have to do some experimentation. And I'm guessing that this is about 7, maybe 800 RPM here. Maybe a little fast. We'll try to drop it down to around 600 and try that. Now I'm watching my calibrations on the RAM, and after you get in a ways, the chips are going to start to back up behind the drill bit, and you need to back the drill out to let those chips clear. So you can do that by turning the hand wheel and come in again. And what's also probably happening, or typically happens, is that the heat of drilling, the friction, causes the oil on the tip of the drill to get burned away or just evaporate or go away somewhere. But anyway, you need to add more oil from time to time if you're drilling a hole that's very deep at all. Now we're coming up on the 3/4 inch mark. Alright, so that's it. So it's fairly typical to have to withdraw the drill bit once or twice or 3 times. You know, the deeper the hole, the more you're going to have to do that. But every time you've gone in about 2 to 3 diameters, it's good to draw the drill bit out to clear the chips. Otherwise, the chips are going to jam up in here. You'll start to overheat. You may burn up your drill if it gets real bad. But at the least, there's a chance that you're going to start to get a hole that is no longer the desired size because it's going to have all these chips built up on it. So be sure to clear your chips out. And while you have the drill bit withdrawn, you can take a brush and clear it off. But be careful because the drill bit often will be very hot from friction. If you're not careful, if you touch that, you could get a bad burn. So if we take a close look at our hole, it looks pretty clean entry hole, and the part of it that I can see, you know, looks smooth. Looks like the drill did a good job cutting in there and not just grinding the material away. But one thing that's always desirable to do, and I pretty much always do it, is to use some sort of a countersink on the drilled hole just to clean off any burrs that might be there. And it also helps with, if you have a shaft that's going to go in there, it will the taper will help the shaft to go in more easily. Well, if you've been reading about mini lathes for very long on the internet, you've probably heard about Jose Rodriguez. He was one of the early users of the mini lathes, or early adopters, way back before I got mine in 1999. He was one of the few people back then who had a website about the mini lathe, and I learned this trick from him on one of his videos. This is just a countersink mounted in a file handle, and you can use that to put a little chamfer on the end of your work. So you just run the lathe very slowly and bring that countersink up in there, put a little pressure on it. That will clean up any burrs that may be on your hole. Sometimes when you're drilling it, it will feel like the drill bit's not making progress, and the reason that can happen is if you don't have the tailstock locked down securely, it will actually slide backwards, or can drift backwards as you apply force on the drill bit. The tailstock will actually move away. So if you are having trouble making progress, you might want to check that and just make sure that the tailstock is in fact tight and not sliding or slipping. Now in this case, of course, we only went in about 3/4 of an inch, but frequently, you know, you need to drill a hole all the way through your work, and basically the process is the same. But the important thing, of course, is you have to continually withdraw the drill bit and clear those chips out. Now if you're going in with a relatively deep hole like that, which might be 10 or more times the diameter of the drill bit, you can unlock your tailstock and just, without using the hand wheel, just pull the whole tailstock back to clear your chips, then bring it back in until it makes contact and lock it down. And that can save you a lot of time on a deep hole, cranking the drill bit in and out just to clear the chips. I did want to mention also that in the terminology of machining, a deep hole is typically regarded as any hole that's deeper than about three times the diameter. So This hole that we drilled is 3/4. We've got a 1/4 inch drill bit, so we're getting on the verge of a deep hole. If I went into a 1-inch hole, 1 inch deep, that would be considered a quote-unquote deep hole. And of course, that's when chip clearance becomes important, and using lubricant becomes very important because friction's a much bigger factor. Well, now that we've covered some of the fundamentals of drilling on the mini lathe, I wanted to step back and talk about a few variations of different mini lathes that are available on the market. And if you've looked at them at all, you're probably well aware that one of the key factors is the bed length. And they're all 7-inch swing, so when you hear, for example, of a 7x16 inch lathe, which is what this is, it means the largest diameter that you can rotate over the bed is 7 inches. And the 16 inches refers approximately to the length of the bed, that is from the headstock to the tailstock. Now, the mini lathes actually are sold in 4 different lengths, and the longest is the 7x16, which is approximately 16 inches from the headstock to the tailstock. The next size is the 7x14, and I've made some 2-inch marks here along the bed to make this a little bit more evident. And so if you had a 7x14, your bed would end here, and then if you had a 7x12, your bed would end here. So one of the things you can quickly see from this is if you have a relatively long drill bit in the tailstock chuck, the amount of room that you have left to work is shorter, depending on the bed, obviously. Now, the next size down from the 7x12 is called the 7x10, which would take us to here, and our 1/2 inch drill bit now is too long to fit in that space. But the lathe that is referred to as a 7x10 is sold by Harbor Freight, and I've actually owned 2 of those over the years, and if you measure it, you'll find that it is actually only a 7x8. So the bed length on the so-called 7x10 actually ends here, and you can see there's no way you're going to get that 1/2 inch drill bit in there. So if you've already bought your lathe, that's sort of a done deal. But if you're still in the process of making a decision about which lathe to buy, keep that in mind, because it can have an effect on your ability to do certain jobs. Now, the 7x10 or 7x8 is what it really is not a bad little lathe, but it is quite short, and so if you're planning to work on relatively large pieces of work, longer than 2 or 3 or 4 inches, then you probably are going to be wanting a longer lathe, like a 7x12 or longer. But if you're working on model ships or something, and all of the work that you do is very small, the 7x10 may do that without any problems for you. So, but if you ever plan to use a long drill bit, keep that in mind. And as we saw earlier, you can mitigate that a little bit by going to the so-called screw machine drills, which give you the same diameters but in a shorter length. But there you can only drill whatever depth that'll give you. Well, now that we've covered that, I wanted to mention a couple of other differences you'll find across the different mini lathes. This one has what is called a lever locking tailstock. So this lever back here, you just clamp that down and it draws a plate up underneath the ways and clamps the tailstock in place. These are found on a few varieties of lathes, but many of the lathes don't have this adjustment. They just have a nut and a bolt here, and in order to move the tailstock, you have to take a wrench and loosen the nut, slide it, and then take your wrench and tighten the nut. So that's fine. It works great, and you get used to it, but this is a lot more convenient, and certainly if you have the opportunity to get the lever locking, that's a nice feature to have. One other thing about the tailstock, it's the way it's designed, it's kind of top heavy. It's very top heavy, really, and it has a tendency to want to tip over. That's annoying at first, but eventually you learn to grasp it down low when you want to move it. So if you hold it down here and slide it down near the base and keep a little downward pressure on it, you can avoid most of that tendency for it to tip. Let's take a look at the chuck and how it's held in place. Now if you already have a mini lathe, you no doubt know that to remove the chuck, you lock your tailstock down and then just turn the tailstock hand wheel in the direction that retracts the ram, and once the ram is even with the front of the tailstock casting, if you continue to turn it, it will force the tooling, whatever it is, in this case a drill chuck, will be forced out. What happens is when a tailstock ram retracts, the arbor that holds the chuck is forced back against the tip of the lead screw, and as that ram goes back in here, the lead screw eventually forces the tapered arbor out. In order to replace it, you have to bring the tailstock ram out beyond the 0 mark here. You want to make sure your tailstock's locked down so it doesn't move. Then what I like to do is just get the chuck in position here loosely, and with the jaws withdrawn all the way, just take a whack with my palm of my hand, and that force is enough to seat it firmly inside the ram. There's quite a lot of force imposed on this taper, which is all that's holding the drill chuck in place. So if this taper isn't locked up tightly, the torque on the drill bit can actually cause the taper to break loose. Not broken in any sense that it's ruined, but just loses its grip, let's say, and then the chuck will start to rotate inside the spindle, and you want to avoid that because that can actually cause some scouring or gouging of both surfaces if it goes on too long and you get heating in there. So in order to avoid that, anytime you put the chuck in place, you want to take a rag that's fairly clean, or you can take your hand if it's not covered with chips, but you want to make sure that there are no chips adhering, or grit or anything, no foreign matter adhering to this tapered area. And the same thing inside here. You can get little tools that'll fit in here to clean it out, but you can use your finger or put a little piece of rag on your finger and run it in there. But the idea is you don't want any oil or grease or any foreign material, chips or whatever, getting in between those two taper surfaces, or they won't lock up properly. And another effect is that if you had a foreign particle of some sort in here, could actually cause this to be skewed a little bit so that your drill bit is no longer exactly in line with the headstock. We've seen that the mini lathe will drill a 1/2 inch diameter hole in steel without too much trouble. Let's try this 5/8 inch diameter drill bit and see how it does. I'm stopping the feed periodically to break up the chips. Alright, we made it through. When you've completed a drilling operation, or if you start to get a lot of chips built up or a lot of shards of metal, you want to stop the lathe and clear those out of the way so they don't get dragged up in there and cause trouble. And you definitely don't want to grab them with your fingers, particularly with a harder metal like steel. These shards can have extremely sharp edges on them, razor sharp, and will slice your finger in a minute if they get snagged on something. So always use needle nose pliers to withdraw them. Well, that wasn't too bad. It strained a little bit, but it got the job done. Let's try now with a 3/4 inch diameter drill bit. It's not liking that. It jarred the chuck loose. Typically on lathes and other machine tools, drill chucks are held in place just by a taper, and under normal circumstances the taper holds very tightly, but it is possible, as we just saw, to create a situation where it can't hold under the forces involved. But we were doing sort of an extreme cut for a small lathe like this. This would be a convenient time to demonstrate how to seat the taper. I like to just sharply wrap the end of the tapered arbor on a tabletop, and that will drive the other end of the arbor up into the chuck and seat it. So that's all it takes, and that should create a very tight bond. Now it's important, of course, that you don't have any dirt or oil or particles on either surface of the taper. It won't lock up properly. So I think we've pretty well demonstrated that the largest practical hole that I can drill with a drill bit, at least in steel, is 5/8 of an inch. So if we need a larger diameter hole than 5/8 inch, at least in steel, we'll have to resort to boring, and that will be the topic of another video, but I'll just give you a quick demo here. So here's our little bored workpiece, and we'll go into a lot more detail on that in a subsequent boring video. Not that this one is boring. Well, having now done some drilling demonstrations, let's consider the various types of drills that you can get. This is a fairly standard set. This one is from Harbor Freight. It's probably 8 or 10 years old, so they may not sell this exact set anymore. But in any case, this is a fairly typical set of inch-sized drills running from 1/16 of an inch up to 1/2 inch diameter in increments of a 64th. So these are very handy to have. Many of the projects you may come across or machines that you may work on may have metric parts in them and require metric size holes, so you'll probably need some metric drills. The sets of metric drills are not quite as easy to find as inch-size drills. You can find good sets of them, but they're often quite expensive, you know, in the range of $80 to $100 and up. But this particular set I got from Grizzly, and it goes from 1 millimeter to 6 millimeters, and it's in increments of 1/10 of a millimeter. So it's a pretty good little set. I've been happy with it so far. Now, one set of metric drills I did find at Harbor Freight that actually is very handy for small holes is this 30-piece mini drill set, and it runs from 1/2 millimeter up to 3 millimeters. So these are inexpensive and very useful for small holes. Now, in addition to metric and inch-size drills, a very common set of drills used by machinists are these so-called number drills, and these are standard size. They range from number 1 is the largest, which is, I believe, just a little under 1/4 of an inch, down to a number 60, which is a pretty small drill. But these are great for filling in all the gaps between the inch-size drills, and they're also specified frequently, as the proper size drill for a tapping operation or whatever. So it's very useful to get one of these sets. Now, another type of set that's pretty handy. This would be a good set to get starting out if you can find one and you like the price and the deal. But what's good about this is you have a complete set of the standard inch-size drills from 1/16 up to 1/2 inch by 1/16. Then you have a set of number drills from 1 to 60. And then over here, you have what are called the letter drills. And these are useful because they fill in a lot of the gaps that you don't find in the inch-size drills, but they run up to sizes that are larger than the number-size drills. Some of these, in fact, are duplicates of standard inch-size drill. I believe an A size, for example, I think is the same as a 1/4 inch drill. So you do get some duplication there. Of course, we've already talked about the short so-called screw machine drill bits and the benefits for them on the short mini lathe. And last, these little tiny number drills. These extend the range of our number drill set from 61 down to 80. So these range in size from a number 61 at the large end, which is 39 thousandths, down to number 80 at the small end, which is 13.5 thousandths. Very tiny little drills, but I've found uses for them over the years. Another thing I find very useful is a chart like this, and I don't know where I got this one, but you can, if you search on Google for drill size charts, and especially search under images, you'll find a whole slew of different formats of charts. But I like this particular format because it lists all the drills: number drills, inch drills, metric drills, letter drills in sequence strictly by size. So it starts with the smallest at number 80 and goes on up. The advantage of a chart like this, if you know you need a hole of a particular size, maybe you have an odd piece of machinery that you're trying to fit something to, you can look on this chart and find the nearest size to it. Let's say it's a 5.4 millimeter, but you don't have a 5.4 millimeter drill. Well, you could see that a number 4 drill is just a little bit smaller. A number 3 drill is just a little bit larger. So it gives you the ability to find the closest drill to the one you really need. Now, as far as the quality of the drills, it's safe to say that American-made drills are still generally superior to the inexpensive imports that you'll find. But it's been my experience that the import drills from China in particular have gotten steadily better over the years. Now this set I got, I don't know, maybe 10 or 12 years ago, and I've labeled the box wobbly drills because I found that a number of the drill bits in here are not concentric. When you put them in the chuck, you can visibly see that they're skewed, and hence the name. So I save these, and the larger size ones work fine. It's the smaller ones that are not very good. So you may have to search around to find some that are decent, but in general, the ones I've been getting from Harbor Freight in the last few years have been fine for hobbyist type work. But if you have unlimited funds, you know, or as your finances permit, you may want to invest in some American-made drill bits as well, which generally hold up better and are dimensionally accurate and just all around better quality for the most part. We've looked at the large size holes that can be drilled on the mini mill, and as a closing gesture I thought we'd look at something small. So I've got a little piece of brass 1/8 inch diameter stock, and I've turned it down a little bit, and I have my number 0 center drill in place, and I'm just going to put a tiny dot of a hole in the center there. Okay, that's all we need to start the hole. Okay, I've got a number 70 drill bit in place, and you can see I put a drop of cutting oil on there hanging off of there. But because it's such a small diameter, we'll use a high RPM. Silent peck drilling, if you want to call it that, which is going in and out, clear the chips. Hey, and I managed to do it without breaking the drill bit. That's not too bad. One thing that surprised me is that this chuck that I got from LMS, LittleMachineShop.com, was able to grip this tiny little drill bit. So that's a number 70 drill bit, and it's 23 thousandths in diameter. Well, there's our tiny little hole. Not too bad for a cheap lathe, huh? Well, that wasn't much of a challenge. Let's cut off this piece and go for something smaller. Well, first we'll bring our center drill up here and make a little starter hole. Getting a little wobble there. Forgot to use cutting fluid, but brass cuts pretty well without it. Just to give you a sense of the scale here, this is a number 60 drill bit. That's the smallest size in our set of number drills. The drill bit that we're using came from this little set here, and these are truly tiny little micro drills used, I think, primarily for drilling tiny holes in electronic circuit boards and maybe for other scientific and engineering purposes. But the particular drill bit we're using here looks like it's 20 thousandths in diameter. Okay, we've looked at drilling small holes, drilling large holes, and many other aspects of drilling on the mini lathe. One thing we didn't get time to do was get to drilling square holes, but we'll look at that another day after I get some more square drill bits. Anyway, I hope you enjoyed this video, and thanks for tuning in. So we'll see you next time.